Discuss the uniform convergence of the series summation n going from 1 to infinity on sine of nx divided by n the power p, where p is strictly greater than 1. So such kind of examples are solved by the weierstrass M test, which is very important. And there is a very important recall over here that summation n going from 1 to infinity on 1 over n the power p is convergent if and only if this p is strictly greater than 1. So if p is greater than 1, then we say that such kind of series is convergent. Right? So this result is also very helpful. Let's start with the solution. This is your given series where p is strictly greater than 1, and we are going to use the weierstrass M test over here. Let's recall the weierstrass M test again. It states that if summation n going from 1 to infinity on mod of unx is less than equal to summation n going from 1 to infinity on mn, for all x belonging to E where this series is convergent, then the summation n going from 1 to infinity on unx converges on E uniformly. So to discuss the uniform convergence for the given series, we are going to use this weierstrass M test, which is very helpful in this case. So in this given series, this is your unx. Right? So let's consider this left hand side first. Let unx is equal to sine of nx divided by n the power p. So considering summation n going from 1 to infinity mod of this unx, that is equal to summation n going from 1 to infinity mod of sine of nx divided by n the power p, which can be further written as, I'm writing this in the next page, the summation n going from 1 to infinity mod of sine of nx divided by n the power p. Is it okay? Yes. Please note that mod of sine of theta is less than equal to 1 for all theta belonging to the real numbers. So here your theta is nx. So now I can write that summation n going from 1 to infinity less than equal to 1 divided by n the power p. And it is given to us that p is strictly greater than 1. So now I am going to use that important remark, this one, that infinite series 1 over n the power p is convergent if and only if p is strictly greater than 1. So here I am having this p to be strictly greater than 1. So by that remark we say that this series is convergent. And this is nothing but your mn. So according to weierstrass M test, if summation n going from 1 to infinity mod of unx is less than equal to summation n going from 1 to infinity mn, for all x belonging to E where this series mn is convergent, then this infinite series converges on E uniformly. That is, the given series is now converging uniformly on E. Right? So if this is your mn, so we write further that, but summation n going from 1 to infinity 1 over n the power p is convergent for p is strictly greater than 1. So by weierstrass M test, the infinite series unx, and what is unx? This one, converges uniformly on R, where p is strictly greater than 1. So hence this series is uniformly convergent on R for p strictly greater than 1. Thank you.